So, welcome back to the shop. I have a small customer job and it's these plastic parts with the V grooves cut into them. They are 200mm long, about 50mm wide, and they have 40-degree V notches cut into them. Material is black PVC. I decided to cut these V's on the shaper because I expected a way better surface finish and also expected it to go faster than on the milling machine with a V bit, with a V engraving bit. So let me talk you through this. I had to make a table extension out of cold rolled mild steel because the table of the shaper is only 180 something millimeter long, and the parts actually are 210 millimeters. I have 6 hold down screws which just clamp the part on this lip down here down to the table extension, and the parts slip out like this. The table extension has dowel pins in here, here and back here as a backstop for alignment of the part, so I don't have to indicate every single one in. And as you can see, I get quite a good burr-free result. Only down here I get some burr, which will come off with a surgical blade. And the side actually gets glued into another, so don't worry about that. This is the show side, and I have absolutely no burr here. So, table extension is bolted to the table back here and has 2 strap clamps here which hold to the table. It's aligned to the travel of the ram, and we're good to go. Okay, let's load in another one. I have small pieces of phenolic glued on the back side, on the rear side of the washer, so the washer stays level when we tighten them down. Okay, move it up against the stop on the back and tighten it down, starting in the center. We don't need a whole lot of clamping force because the part is pushed against the stopping pins back here. And yes, we're cutting on the pull stroke, and I know that I will get the question in the comments, why am I cutting on the pull stroke with the shaper? There are a few reasons. First of all, it looks cool. Second of all, the chips don't fly all over the shop because they go that way against the column of the shaper. And third, when you do heavy cutting, the cut is more stable because all the cutting forces are directed against the column of the machine and against the box ways. If you're using the push type clapper box, all the cutting forces hang on the closing gibs of the boxways, and that's the weakest direction of the boxway. So that's the reason why I like to have to push pull type clapper box on here all the time. And when you look on my website, I have a short page on the pull type clapper box with a set of measured drawings, which should also fit roughly a 7-inch self-bend shaper or a Gustel RG200 shaper, or one of those small 200 to 300 millimeter stroke shapers. If you want to build your own, you can take this set of drawings. It's free. So I'm set up. Now I'm going to align the tool with the edge of the part, and we're off to cut the V's. Okay, the V grooves have an even spacing starting out from one edge of the plate, and here I'm aligning the tip of the cutting tool with the edge of the workpiece using a magnifier, just aligning it visually until the tip of the tool is right above the edge of the workpiece. Then I zero out the dial on the table cross traverse and move over the table the desired distance. And of course, as usual, I go too far. I go back, take up the slag or the backlash and go to the right distance. And then I zero the dial out right away. Using a gauge block to pick up the depth of cut. That's the depth where I want to cut to. And then also zeroing out the dial on the top slide of the shaper. And there we go, cutting the first of the V-grooves. And you will notice that the cutting tool makes a horrible noise, and that comes from the fact that it is a 0-degree chip rake and quite large engagement of the cutting tool. And that leaves in this screaming noise. So there we're done, ripping off the swarf, which collected at the end of the cut, retracting the tool, moving over the table one increment of which was in the drawing mentioned, and cutting another one. You can see that the chip comes out of the groove very nicely, and I don't get much burr at all. I did some experimenting with cutting oil and soluble oil, but it wasn't very good. When you do something like this, you just let the hand rest on the top slide and let it go with the shaper to advance the cutter. And we're almost down to full depth. Ripping away the chips and retracting the tool. Okay, we're pretty much finished. Only have to take it out and deburr it. And as you can see, the screws are not really tightened down. When you work with plastics, you don't need to crank down on every single screw until you strip the thread, because you will mush down the material. There you go. Another one of these washboard plates done. 9 to go. So maybe this quick video was interesting for you, showing that the shaper can actually do some productive work. Thank you all for watching, and see you next time.